Hello and welcome. Today I'll be showing you how to factorize perfect squares. Let's get started. Before we go on to factoring perfect squares, first we need to know what perfect squares are and what are the rules guiding perfect squares. So, sometimes you're going to come across some expressions that are written in this form. So let's say P minus Q, all in bracket, squared, and P plus Q, all in bracket, squared. So these two are called perfect squares. You can see that they're within a bracket, unlike difference of two squares that is outside of a bracket. So difference of two squares is P squared minus Q squared. So we see there's a difference between P minus Q that is within a bracket with a square, and P squared minus Q squared which does not have a bracket. The one that doesn't have a bracket, P squared minus Q squared, is called difference of two squares. But the one that is within a bracket, P minus Q squared, is called a perfect square. Okay, so the perfect square can have a negative sign or a positive sign. So there are actually two of them. So when you see two numbers written within a bracket with an addition sign between them and outside the bracket that is square, know that that's a perfect square. Okay, what do we mean by perfect square? Let's use some numeric examples. So let's say we have 3 plus 4 squared. So what does that mean? So this means 3 plus 4, because we have to do the addition within the bracket before we do the squaring. So 3 plus 4, that gives us 7, and then 7 squared gives us 49. Can you see that's a 49 is a what? Perfect square, isn't it? Okay, now, but if we have let's say let's say 4 minus 2 bracket squared. Now this is going to be 4 minus 2, that is 2 raised to the second power, that is 4. So we see that 4 is also a perfect square. But let's now see the difference between these and difference of squares. So difference of squares, instead of it being within a bracket, so it's going to be 4 squared minus 2 squared. So what is 4 squared? That is 16. What is 2 squared? That is 4. The difference of the two is 12. But here we see that 4 minus 2 with a bracket outside the bracket and then a square gives us a value of 4, whereas 4 squared minus 2 squared gives us a value of 12. This shows you that they are different. So difference of two squares, you have to understand that there's a difference between the difference of two squares and perfect square, particularly the one that has a negative sign that goes along with it. So don't confuse the two. Okay, now let's go on and look at the rules. So when you have a perfect square like P plus Q squared, when you expand it, we're going to look at the expansion later on in a future lesson, but the expansion is usually in this form: P plus 2PQ plus Q squared. Sorry, P squared plus 2PQ plus Q squared. Let's look at the other one, that is P minus Q squared. So when it is fully expanded, it becomes P squared minus 2PQ plus Q squared. Now, what do you notice about these two? We see that the center component, the one that contains the P and the Q, is a multiple of 2, right? It's a multiple of 2 in both cases. The difference between them is that the one with the negative sign has a negative sign in front of it. The one with a positive sign has a positive sign in front of it. So that's the major difference. But otherwise, we notice that the two terms, the P and the Q, when you multiply them together, P times Q, what you have is twice the value of it when you fully expand it. So this is what helps us when we are trying to factorize perfect squares. So when you see a term like x squared minus, let's say, 2x plus 1, then you know that this is likely to be a perfect square, and it's of this variety, P minus Q variety. It's of that variety. How do I know that? Because if you look at this, this is 2 times P and Q. You know, what is P here? P here is what? P is equal to 1. Q is also equal to 1, isn't it? So when you multiply that, 1 times 1, what do you have? 1. And then 2 times that, isn't it? That is 2. So we see that we have a perfect square there. So that's the whole essence. The value of the P and the Q, when you multiply them together, you always get 2 times the value in the middle. The difference between the positive and the negative form is that there's a positive sign for the positive form and a negative sign for the negative form. Now let's look at a few examples. Factorize x squared plus 12x plus 36 using the perfect square method. So first, let's write this out differently. So this is x squared plus 12x plus 6 squared. Okay, so here we see that we have the P squared and then we have the Q squared. If you remember, the perfect square usually has this form, particularly the positive one, P squared plus 2PQ plus Q squared. Okay, so what is P here? P here is 1. What is Q here? Q here is 6, isn't it? Okay, now we also have 2 times P times Q right in the middle. So let's see whether 12x is 2 times P times Q. So what is 12x here? So this is we can break it down. Do we have so it's supposed to be PQ, so PQ is supposed to be what? 6 times 1, okay, or 1 times 6 rather. And so let's write that. So that is 6 times 1x. Okay, now we said the value in the middle is 2 times PQ, so 2 times PQ. So if you multiply 2 times 6 times 1, that gives you 12. So 12x is actually 2 times 6 times 1. So what we have in essence is what? A perfect square. So this is in perfect square form. So we have actually checked that, okay, x squared plus 12x plus 36x is a perfect square. So now that we know it's a perfect square, the next thing to do is to try and factorize it. So how do we factorize it? So what you need to do is we write it out as x squared plus 12x plus 6 squared. Okay, so we'll also write x squared plus 2 into 6x plus 6 squared. Okay, so now that we know that, if we recall, we know that P squared, actually I didn't mention the P squared, P minus Q, P plus Q squared is the same as P plus Q squared, P plus Q rather, into P plus Q. Okay, P plus Q into P plus Q. So what is our P here? The P here is equal to 1. What is our Q here? The Q here is equal to 6. So now we can go ahead and use this formula to factorize it. So we say this is x, which is our P. Our P here is 1, isn't it? But we're not going to write 1, we're going to write x. So it's going to be x plus, what is the Q? 6. into bracket x plus 6. So once we have satisfied the rule for the middle value to be 2 times the value of the last term, then we can go ahead and factorize it. So when we factorize it, we make it x plus 6 into x plus 6. So what is x plus 6 into x plus 6? We can write it differently as x plus 6 in bracket squared, because you know that when you have x plus 6 with the bracket squared, it means x plus 6 into another x plus 6. So factorize using the perfect square method. 3x squared plus 48x plus 192. Okay, remember a perfect square like p plus q squared is the same as p plus q into p plus q. You don't want to forget that. And the same thing if it's a p minus q squared, it is so when you factor it out, it becomes p minus q into p minus q. So that is what we mean by perfect square. Okay, so now let's examine this expression. Is it a perfect square, just like we did the last time? It doesn't appear so with just one look, but let's try and do something to this expression. What can we do to it to make it look like a perfect square? Okay, so because the values are really big, so you can factor 3 out of it. So 3 into x squared, 48x divided by 3 is 16x plus 192 divided by 3 gives us 64. Okay, so what's the next step? The next step is now we need to factor x squared plus 16x plus 64. So what is the p here? The p here is equal to 1. And what is the q? The q here is equal to, remember, we can write this as 3 into x squared plus 16x plus 8 squared. Okay, so q is equal to 8. Okay, now can we write the middle number as a multiple of 2 of these two numbers? Okay, let's do that. So that's going to be x squared plus 2 multiplied by 1 multiplied by 8 multiplied by x, isn't it? Okay, instead of writing just 1, so 2 multiplied by x, we know x is just 1, so plus 8 squared. Okay, so now we have written it in the form of the perfect square, completely expanded perfect square. So now we know that this is a perfect square, and so therefore we know that p is x, isn't it? And we know that q is 8. So therefore we're going to say this is 3 into what? X plus 8 into x plus 8. And what is x plus 8 into x plus 8? Well, that is x plus 8 squared. So we can go on to say that this is 3 into x plus 8 squared. So in this question, we are asked to factorize using the perfect square method of negative 2x squared minus 28x minus 98. So we don't immediately see a perfect square in the last term of this expression. So, but we can, it's been marked by another number. So let's factor out negative 2. So negative 2 in bracket, so 2x squared, negative 2x squared divided by negative 2 gives us x squared. So negative 28 divided by negative 2 gives us what? Positive 14x. Okay, negative 98 divided by negative 2 gives us positive 49. Okay, now we see 49. 49 is a perfect square, so it's easy for us to work with now. So the next step is negative 2. We want to see whether the middle term is in the form of 2 times of the the first and the second term. Remember, the first term here is what? The p here, which we use as representing the first term, is what? X. Okay. What about the q? Well, we know 49 can be written as 7 squared, isn't it? Okay, plus 14x plus x squared. Okay, so q here is 7. Okay, now we know the q and we know the p. Okay, so can we write the middle term as 2 times x times 7? Yes, we can. So that's going to be x squared plus 2 times 7 times x plus 7 squared. So now we have it in the form of the perfect square. So we can go ahead, since this is true, we can go ahead and now factorize it. So this is going to be negative 2 into x plus 7 into x plus 7. Okay, remember it's positive sign all through. That's why we're using the positive sign. If it's a negative sign at the second term here, then we're going to use a negative term. Okay, so this is negative 2 into x plus 7 into x plus 7. X plus 7 into x plus 7 can be written as a single term, so we're going to write this negative 2 into x plus 7 squared. Okay, so factorize using perfect square method. 4x squared minus 4x minus 4. Here we're not going to divide through by 4 as we have always done. The reason why we're not going to do that is because 4 is a perfect square itself. You know, perfect square are integers that can be squared to give another integer. An integer that can be squared to give another integer. So if we square 2, it will give us a value of 4. 4 is an integer, 2 is an integer, isn't it? So if we square 3, it will give us a value of 9. So if we square 4, it will give us a value of 16, and so on. So perfect squares are numbers or integers that you can square, and and then it will still give you an integer. Okay, so 4 in this is an integer. But you might ask, in the last two examples that we had 3, we had negative 3, we had negative 2. Well, negative 3 is not a perfect square, because there's, what do you square? What integer do you square to get negative 3? No, none. What integer do you square to get negative 2? None. So that's why we divided through. So when you look at the first number, if the first number is not appearing to be a perfect square, then you go ahead and factor it out. Okay, so here we're not going to factor it out, we're going to write it differently. So we're going to write it as 2x squared, because 2 squared, you remember 4x squared is the same as 2 squared x squared. So when you now go ahead and factor out the power, because the power of 2 is the same there, so we can write it as 2x squared minus 4x minus, and then 4 is the perfect square, so we can write it as 2 squared. So here we see that the first term and the second term are squared. Okay, so now what is our p? Our p here is what? Is 2x, isn't it? What is our q? Our q here is 2, isn't it? Okay, sorry, this sign is a positive sign, so it's not a negative sign, it's a positive sign. Sorry for that error. Okay, so 2x squared minus 4x plus 2 squared. So we see that our p is 2x and our q is 2. So now we can go ahead and check the middle term. Is the middle term in form of 2 times 2x? Okay, that's what we want to find out. So this is 2x squared minus 2 times 2x plus 2 squared. Okay, now we see that the middle term is in form of 2 times 2x. So this is a true perfect square. So we go ahead and we factor out. So we know our p, we know our q. So what is p? 2x. What is q? That is 2. 2 minus 2x into minus 2 into the reason why we're using a negative sign here is because the negative sign is in front of the middle term. Okay, remember, the middle term determines whether you're going to use a positive number, positive sign, or a negative sign. So here it's a negative sign, and so we use a negative sign. In all the other examples, we've always had a positive sign in front of the middle term, and that is why we use positive sign. So here it's a negative sign, so we're going to use the negative sign. So 2x minus 2 into 2x minus 2. Okay, so what is the next thing to do? So the next thing to do is to what? Combine them together. So that's going to be 2x minus 2 squared. So that is 2x minus 2 squared. But we see that this is not completely factorized. So what can we do? So at this step of 2x minus 2, we can actually do something here at this step. So we can write 2x minus 2, we can factor out 2. So this is going to be what? 2 into x minus 1, and then 2 into x minus 1. Okay, so if we multiply 2 and 2, that gives us 4. So x minus 1, 2 of them, so x minus 1 squared. So when you expand this and you multiply through with 4, what you obtain is 4x squared minus 4x plus 4. So, and the same thing, if you decide to divide through by 4, you still obtain x, but this time what you get is x minus 1 squared, and that will be wrong. But the answer is actually 4 into x minus 1 squared. So now let's factorize x squared minus 6x plus 9. So we rewrite this as x squared minus 6x plus 3 squared. So our p here is x, our q here is what? 3. Okay, so can we write the middle term as 2 times 3 times x? Yes, that's possible. So that's going to be x squared minus 2 times 3 times x plus 3 squared. Okay, now we can factor out, so this is going to be x minus 3 into x minus 3. Okay, so we can combine the two, it becomes x minus 3 squared. So you want to remember that when you have p plus q in a bracket squared, fully expanded form of it is p squared plus 2pq plus q squared. And it's important for you to notice that the first term p is squared, the second term q is squared at the end of it, and then in the middle term there's p and q are multiplied together, p times q, and then two of them usually have 2 times of that, so we see 2pq. And then because there's a positive sign here, we have a positive sign in front of the middle term. So the reverse is also possible. When you are presented with an expression like this, p squared plus 2pq plus q squared, you know that what it actually translates back to is what? P plus q squared. Okay, then the negative is also true. If you have p squared, so if you have p minus q all in brackets squared, fully expanded form as a squaring of the first term, which we see here as p squared, squaring of the second term, which we see here as q squared, and then there's the middle term is twice the product of the two terms, and it has a negative sign in front of it. So the reverse is also true. If you have the fully expanded form given to you for you to factorize, you can easily factorize it back to p minus q squared. So the most important thing is to be able to identify that the expression you have given is actually a perfect square. And following this rule, where you know the expanded form and you know the factorized form, helps you in identifying it and quickly factorizing it that way. You want to relate the above relationships whenever you have an expression that is written that looks like a perfect square. Sometimes the examiners are very smart and they hide the perfect square. So it is left for you to unmask the perfect square. One of the ways of unmasking is divide through by a factor that you can recognize that can easily go through. It could be 2, it could be 3, it could be 4, it could be 7, it could be any number. So it's important for you to be able to recognize that and then for you to expose the perfect square. So at the end, at the last term, in the expanded form, you should be able to identify a perfect square there. Once you identify a perfect square there, then it's easy for you to look at the first term. It's also a perfect square. Then you can quickly deduce by looking at the middle term. Is the middle term twice the product of the first and the second and the last term? If it is, then it's a perfect square, and then it's easy for you to quickly factorize. That's it on factorization of perfect squares. Thank you for watching.